Hello, my name is Mason Adams, and I'm a computer engineering major here at Alfred State College.
And I'm Sal Costa, a mechanical engineering student major here at Alfred State College.
This is our project presentation for the BSET 8003 Senior Project. Our project is a drivable robot controlled from a laptop that also provides a video stream of what the robot is viewing. In this presentation, we will be discussing the hardware and fabrication, design and CAD work, programming and operations, and some possible applications of our project. Now we'll be discussing the hardware and fabrication of our project. The hardware that we used was initially a Raspberry Pi 3, which is a small single-board computer. Then we also had an Easy Connect board, which expanded the output pins of the Raspberry Pi. This allowed us to make a voltage divider circuit in order to bring down the voltage returned from our sensors that we will be discussing later. And this is necessary to bring the voltage down to a level safe for the Raspberry Pi's pins. We also used an Adafruit DC and stepper motor hat. This board allowed us to connect our motors to the Raspberry Pi and have a fully dedicated pulse width modulation driver. We also used the Raspberry Pi camera module version 2. This was used with our Raspberry Pi to provide the video stream. We also used 4 micro metal gear motors with a 50:1 gearbox ratio. Lastly, we had 2 ultrasonic distance sensors. These sensors output a frequency and then measure the time it takes for the frequency to be returned in order to calculate the distance.
For a chassis fabrication, we decided to use 2 pieces of plexiglass since they're both lightweight and sturdy. And they're kept up by 2.5 millimeters standoffs. And we have 4 moon buggy wheels that are attached to 4 micromotor mounts. And for our networking equipment, we have a wireless dual band router that produces a Wi-Fi signal that allows the laptop to communicate with the Raspberry Pi. Now for our CAD design, our robot was modeled using SolidWorks, and we felt like we should ignore the wires since it didn't seem as necessary to add them. And here you can see the top view, front view, side view, and the isometric view in true orthographic projection. And this is different compared to our original AutoCAD drawing that we had of this. This was mainly due to the fact that many parts were not available at the time, so our design had to drastically change due to what was available. So we worked with what we had.
Now I'll be discussing the programming and operations of our robot. First, in order to connect the laptop to the Raspberry Pi, we used a remote desktop connection through our Wi-Fi connection. The programming was done in Python using an object-oriented approach. The first file that I created was the robot file. This file contains methods that set up the robot's sensors, read the front and back sensors, turn off the motors, change the speed of the motors, and then move forward, backward, and then rotate left or right. I also created a sensor file. This file is used to actually create the sensors inside of the robot file. This contains the pin outputs for each sensor that are connected to the Raspberry Pi. And then lastly, I also have an environment file. This file draws the graphic user interface for both the sensors, and then allows you run this file that creates the robot file. This file contains the logic to read what button is being pressed on the keyboard and then calls the corresponding method from the robot file. I also have 2 scripts, one on the laptop and one on the Raspberry Pi. The first script on the Raspberry Pi uses the Raspavid command that is packaged with the Raspberry Pi camera module. This is in order to start the stream, which is then piped to an application called Netcat that sends the stream to the IP address of the laptop. The script ran on the laptop, receives the stream through Netcat, and creates a viewing window through the MPlayer application. In order to operate the robot, the graphic user interface has arrows corresponding to the arrows on the keyboard, and those are what allow you to actually drive the robot. I also included a 1, 2, and 3 image that correspond to the keys of the laptop. This allows you to change the speed of what the motors operate through pulse width modulation. Also, the readings of the distance sensors are displayed at the bottom of the graphic user interface. By utilizing the graphic user interface and the window showing the stream from the camera, you are able to pilot the robot without physically watching where the robot is. Here's us operating our robot. The wheel placement allows us to do 0-point turns. The movement's pretty fluid. I'll be driving over the wall now. Our front distance sensor is showing a distance reading of 36 centimeters from the wall. We also have a back distance sensor. And we also have 3 different speeds. Our first speed will be shown here, being the lowest speed. Here's our second speed. And our third speed being the fastest. Here's a video of the laptop screen. As you can see on the left, we have the real-time stream of what the robot's seeing. And on the right, we have this GUI here. The top section shows what speeds you're in. The middle section shows the inputs of the keyboard. And on the bottom, we have the front sensor and back sensor. As you can see, it's very easy to drive without even seeing where the robot is.
When it comes to application for a project like this, it can be used for military and police robots to retrieve and disarm explosives. And the military still uses EOD bots to this day to disarm and even safely destroy explosives in Iraq and Afghanistan. And also technology similar to flying drones, like a UAV, unmanned aerial vehicle, to pinpoint enemy locations to know where the enemy is hiding. And another application is for rovers in space to retrieve data, like what NASA uses for their Mars rover. Now these applications are obviously way more advanced than what we're doing, but it still uses similar technology to what we're doing, but at a basic level. So this has been our project presentation for our BSCT 8003 Senior Technical Project.
For our project, we built, tested, and programmed a drivable robot that's controlled from a laptop that also provides a video stream of what the robot is doing. In this presentation, we discussed the hardware and fabrication, design and CAD work, program and operations. We showed off what the robot is able to do, and we discussed some possible applications.